Okay, so in this company, it says, in this question, a dog food company is launching a new brand of food. The food will be sold in cylindrical shaped tins of radius R and height H. Each tin will have a volume of 98 pi centimeters cubed. Show that the height of the tin can be represented as H is equal to 98 over R squared. Well, I know it's in the shape of a cylinder, and the volume of a cylinder is pi R squared H. Well, I know what the volume is, and I know what the radius is. The radius is in terms of R. So I want to get H on its own, like they have in the question there. So filling in this, 98 pi is equal to pi R squared H. Divide both sides by pi. 98 is equal to R squared H. Divide both sides by R squared. So you're getting H is equal to 98 over R squared. And that's actually going to be centimeters as well, because it specifies that in the question. There, centimeters. So then it says show that the total surface area, S of the tin, is S equal to 2 pi by R cubed plus 128 over R. Okay, well, it's a cylinder, isn't it? So it's important to note that we have the circle that's at the top, the circle that's at the bottom, and the curved surface area. So the area of the circles is going to be 2, because there's 2 of them, and then the area of a circle, which is pi R squared. And the curved surface area from the log tables is going to be 2 pi R H. That's terrible, H. From the log tables, 2 pi R H. And actually, where that's getting you, it's the 2 pi R is getting you the circumference of the circle. The circumference of the circle, and then you're multiplying by how high it is, but you could just take that straight from the log tables. Okay, looking here, the surface area doesn't have a H in it. There's no H in there. So it's really this H that I'm trying to get rid of. So S is equal to 2 pi R squared plus 2 pi R. And what was the H from the previous question? 98 over R squared. 98 over R squared. S is equal to 2 pi R squared plus 98 times 2 is 196. 196 pi R over R squared. Okay, can I add these two together? Yeah, I can. 2 pi R to the 4 over R squared plus 196 pi R over pi R over R squared. Now what I've done here to get to this is I've gone and looked at them and gone, well, I can't add a fraction to a non-fraction. So I've made this first one a fraction. I've turned this into a fraction by multiplying the, I've treated it as 2 pi R squared over 1, and I've multiplied it by R squared over R squared. I multiply fractions by going top by top, bottom by bottom. And the reason I've done that is because I want the denominators to be the same. R squared by 1 is R squared, and I still have R squared over here. So now I can add those two together. S equal to 2 pi R to the 4 plus 196 pi R all over R squared. S is equal to, okay, and I'm continuing, and I'm going to, well, look, that square can cancel because it's dividing in there, and I'd be left with a 3 here. So I'm left with 2 pi R to the 3 plus 196 pi all over R. Now this is relatively similar to this, but it's at this point I've actually paused the video and looked at the marking scheme. So I'll show you the marking scheme. I'm not sure, because I just can't remember. I think there must have been an errata to the mocks, because this is not what the question reads. The question has a 128 in there and not a 98. So I'm sure it is supposed to be 98 and the question is wrong. Hopefully you're not rolling your eyes and going, oh, for God's sake. But I think this is supposed to be 98, which would make sense because when I factorize out the 2 pi, I'd be left with r cubed plus 98 all over r. Okay, so I think that's definitely the answer, and this is wrong, unfortunately. It should be 128. Hopefully that hasn't annoyed you too much. So what have I got so far? I've got s in terms of or, s blah 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 something or, right here, s in terms of or, and I've gotten in the first one h blah 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 in terms of or, h written with an or in it somewhere. Okay, part C. Find the radius of the tin that will minimize the amount of aluminium required to manufacture the tin correct to 1 decimal place. So when is S at a minimum? Because S is actually the quantity of aluminium. Remember, it's the surface area. That's that is the, what's the word I'm looking for? Yeah, S is the quantity of aluminium. So I'm just going to copy this down. Copy. Actually, I'm going to copy the one from above it down. The multiplied out version of it. I prefer the multiplied. So remember, how do I find the minimum? Minimum is found by differentiating and set it equals to 0 and then solve. Okay, so I'm going to find ds dr. How do I know it's ds dr? It's because s is here and the variable is or. Now, there's a variable on the top and bottom line. The top and the bottom line. It's a fraction, so I know I'm going to need to use the quotient rule. So v is equal to 2 pi r cubed plus 196 pi. Sorry, v is not that, u is that, excuse me, and v is equal to or. dv is equal to 1, differentiate or in terms of or, you'd get 1, and du is 6 pi or squared plus a differentiate this. There's no ors, so it's just going to go to 0. Okay, using the product rule, the quotient rule, it's v, so that's or, times 6 pi or cubed, squared, plus u times dv, so it'll be 2 pi or cubed plus 196 times 1. And there's the quotient rule there. I just went and copied it down. Minus u, which is 2 pi or cubed plus 196 pi all over v squared, so that's or squared. Okay, start multiply this out. ds dr is equal to 6 pi or cubed minus 2 pi or cubed minus 196 pi or squared is equal to 0, because I want to find when it's at the radius when the surface area is at a minimum. 4 pi or cubed minus 166 pi is equal to 0 all over or squared. Multiply both sides by or squared. 0 by or squared is 0, so I'm getting 4 pi or cubed minus 166 pi is equal to 0. 4 pi or cubed is equal to 166 pi. Solve this for or then. or cubed is equal to, divide by 4 pi, so 166 divided by 4, 83 over 2. And I'm making terrible mistakes today. This is a 196. My own writing is letting me down. 196. One nine six, excuse me. 196 divided by 4 is 49, or is equal to the cubed root of 49, or is equal to 3.7 centimeters. So that's when it's at a minimum. Hence or otherwise, find the total surface area of the tin corrected 2 decimal places. Find the total surface area corrected 2 decimal places. I would imagine that that is the area that gives a minimum. Okay, so find the area that uses the minimum amount of aluminium. So I'm going to copy that down. It's going to be that from part B, and use it, and subbing in the 3.7 in for or. So what am I getting? S is equal to 2 pi 3.7 cubed plus 98 all over or. You know what? Between the mistake in the question itself and the mistake that I made there, the 166 instead of the 196, yeah, not the best of questions, to be honest. We're cubing that out, plus 98 all over 3.7. The answer is 252.4, correct to 2 decimal places, 44 centimeters squared. I'll show you the marking scheme first quickly as well. 10 marks, 10 marks, 10 marks, and 10 marks. I'll leave that there so you can pause it if you want. Hopefully you found the video useful, even with the error in the question. If it happens in the actual leaving cert, that there's an error in the question, that will of course be read out straight away. So I wouldn't worry about that. Don't assume there's a mistake in the question. Interesting, I suppose, in part C, for the marking scheme, they did not use the quotient rule. They divided the or into the top line. Yeah, they divided it into the top line and just got a negative power on the 1 here. So it's or to the -1, where it's only or to the 2, and then you can differentiate it as normal. So I might just zoom in there. But yeah, as I'm saying, don't you can use the quotient rule as I did. You can. Hopefully you found the video useful.